finite element mesh in STAAD.Pro using parametric models. Now that we've gone over our agenda a little bit, let's also take a look at our platform that we're using today. Now, if you've come to a lot of our special interest group sessions in the past, you're going to notice that our platform that we're using for 2020 and beyond, hopefully, is different than what you're probably used to. So let's go ahead and talk a little bit about what you're seeing on your screen. So this is the On24 platform. We will be using this platform for all of our tech talks at Bentley Systems and also our special interest group sessions and any other webinars that you might enjoy. What you're going to notice is that you have different windows on your screen. Now, all of the windows are resizable and movable, and you can turn them off and on using the different icons within the widget at the bottom of the screen. Right now, you're probably seeing the slides as kind of the main focus of your screen. In a few moments, I will be displaying my screen so you can see my application, my STAAD.Pro workflow, and that will be available in the media player. Once I share my screen, please feel free to go ahead and resize your screens to make the viewing experience the best for you. What you're also going to notice is that I do have a window up there for resource lists. This has some special resources that I thought you might enjoy. Please feel free to click on them either during the session or after the session, or feel free to bookmark them in any of your browsers. These include links to our learning paths for our concrete design workflow in STAAD.Pro. You're also going to find some of our, a link directly to our communities page from Bentley Systems. And I also have some release notes, of course, for the latest version of the RCDC. Now, as we work our way through the information or material today, you are free to go ahead and enter some questions into the question and answer window on your screen. Again, you can go ahead and get that using the widget on your screen, and the widget stays on your screen all the time, no matter what. So please feel free to go ahead and enter any questions you might have. I will be visiting the question and answer window towards the end of this presentation. I'll try to hit as many of them as possible. The last thing on your screen is you are going to be able to see my bio. So of course, you can always feel free to access that and email me after the session if you have any questions or need any recommendations for any further training opportunities you might be looking for. That being said, let's go ahead and move on, and let's talk a little bit about our special interest group sessions. Now, if you're newer to our special interest group sessions, I just want to remind you that within the United States, we do conduct typically one special interest group session for STAAD each month. We typically go on the third Thursday of each month. We're always at 1 p.m. Eastern Standard Time, and we do take 2 hiatuses throughout the year for STAAD and STAAD.Pro. So you can expect to see 10 special interest group sessions for 2020. Now, to see the schedule for the special interest group sessions, we do have that available on the Bentley events page. The Bentley events page does change a little bit, so I'm going to revisit that and make sure everybody has the address for that once we finish up. You can use that Bentley events page to sign up for future special interest group sessions or tech talks. And you can also use that page. That's where all of the recordings for all of our special interest group sessions will be going. Now, one of the main advantages that we have for going with the On24 platform now is that recordings will be happening very quickly after the session. So in previous years, you would probably notice we always say, give us 1 or 2 weeks to get that online. Here it should be within the day. The recording of this session should be available. Now, if you are looking for past special interest group sessions, those are still available in the Bentley Learn system, in the Learn website, learn.bentley.com. So please feel free to go ahead and browse for past options as well. Now, lastly, we do give 1 PDH credit, and those are still available on your Bentley transcript. To achieve your certificate for today's session, you're going to go to learn.bentley.com. You're going to go to My Training History, and you can go ahead and print out a transcript for today's session. So let's move our attention over to our agenda for today. Today, we're going to be designing concrete walls with STAAD.Pro and STAAD Advanced Concrete Design Workflow, or the RCDC. This is going to be a 3-step process. First, we're going to prepare our model in STAAD.Pro by creating our finite element mesh using parametric models. We're going to move our process along by analyzing the model in STAAD.Pro and then sending that data over to the RCDC. And finally, I'm going to show you how we can design those walls in the RCDC, how we can get some drawings and also some calculation information. So let's talk about versions for STAAD.Pro. I will today be using STAAD.Pro Connect Edition, version 22, update 3. Now the update's going to be very important because to achieve this workflow, you will be needing the latest version of the STAAD RCDC, which will be automatically installed when you install this version. And this version, I believe it was this week, just went live in the Connection Center. So it does have a full commercial release available. Now we can use this version to create a finite element mesh using parametric models and then send those walls over to the RCDC. Now, as I mentioned in 2019, I did perform a special interest group session, and in that session on a similar workflow, we were at the point where we had to create our walls in our system as basically member elements, and you had to define basically them as a parametric member, and you had to define the length of the member as basically the length of your wall. And we did get a lot of information or questions after that being like, well, what's that going to do to the stiffness? So what's great about this is you can actually model your wall as a parametric mesh and then send that finite element mesh over. Now, currently right now, it does read in parametric models. It doesn't read in any other type of mesh that you might be creating in STAAD.Pro. So I'm going to spend a little bit of the time at the start of this session showing you how to create a parametric model. So that way you can get comfortable with this workflow in case parametric models might be slightly newer to you or not in your normal workflow for how you would create a finite element mesh. So now that we've given the introduction, let me go ahead and start by sharing my screen, and we will begin. Okay, so hopefully you should be seeing my STAAD.Pro screen on my window. I'm just verifying with someone else, making sure that they can see my screen. Okay, so you should be seeing my screen. Again, it should be showing up in the media window. Feel free to enlarge this. I will be occasionally going back to the PowerPoint, but probably not as much as the main focus of my STAAD.Pro from this point. So please feel free to make it larger for yourselves. So what I have is I have just a very basic model in STAAD.Pro. I've already created some concrete beams and concrete columns. I've already assigned some properties to them. And just for the convenience of this session today, I've already created the nodes at the corners where my walls are going to reside. I'm basically going to create kind of a combined wall over, we'll call this the west side of the structure. And over at the east side of the structure, I'm using left and right as west and east. I'm going to have just a simple wall. And what I need to do is I need to create a parametric model. Now, parametric models are unique in STAAD.Pro as it provides you the ability to create a finite element mesh, and it has some advantages over some of your traditional methods of generating a finite element mesh. The first advantage is that it allows you to kind of preview what your mesh is going to look like before committing it to your model and your input file, which is nice to do because, as we know, sometimes when you want to change a mesh density on the fly, that's not exactly the easiest thing to do once your mesh is already in your input file. A parametric model also is unique for where it allows you to really control your mesh density. It allows you to create density lines. So if you have a particular line of nodes that you want to maintain within the field of your mesh, it allows you to do that. It'll also automatically attach itself to any nodes that are within the boundary. So typically, for example, if I wanted to create a mesh of a floor slab over at this top area using the Generate Mesh tool, I would want to create a separate mesh area within each of these bays to make sure it's attached to the beam. Well, parametric models, that's not necessary because it's going to automatically attach itself to any nodes within the plane of where you're going to create that system. So I'm going to show you how to create your parametric model, and hopefully after seeing this workflow, you'll kind of see that this isn't just something we're just going to use for the RCDC. Perhaps this is a workflow that you may find comes in useful for other situations for which you need to generate a finite element mesh. So how do we get started? In my STAAD.Pro screen, I'm going to go to this parametric models area. Now this model doesn't contain any plates yet. It doesn't contain any parametric models yet. So I'm basically starting from scratch. What it has done when I get to this area is it's kind of dashed all the members in my model, and it's brought over the nodes for me as well. Now let's go ahead and talk about how the RCDC wants us to generate our parametric model. Now we have two different options, and right now I am referring to the PowerPoint presentation in case you minimize that. We do have two options for creating our parametric surface. If we have a wall that goes multiple stories, we are able to just kind of create one parametric mesh over the entire wall face. Okay, so that's available. But we also have the ability to just create it on just one story at a time, which is actually the preferred option. So that's the course that I'm going to take today. So I'm going to create one wall for each level of the structure. What I did find by using this technique is that my mesh that is eventually generated becomes much more regular, because if we were to take a look at, let's go ahead and call this our west wall again. If we were to take a look at the west wall by ensuring that it's attached to all interior nodes, it gave me a very kind of random mesh because as I was trying to kind of attach to this center node. So if I have just one level at a time, that becomes just a very straight rectangle. There's actually no nodes in the plane of that. So my mesh actually became much more regular. So let's start by creating our first parametric model. And I'm going to highlight the preview models option. And I'm going to click the add button. You're going to see your cursor is going to change a little bit. And what we're going to do is we are going to select the, oh, lost my cursor. There we go again. Okay. And what we're going to do is we are going to select some nodes in an order. You do want to go in consecutive order around the perimeter. It is not necessary for these nodes to be, they should all be in the same plane, but it's not necessary to just do like a 3 or 4-sided shape. You can, whichever shape you have, you can enter. You're not limited just 3 or 4 nodes. So I'm going to click the 4 nodes of my first wall. If I'm ready to close the polygon, I can click back at my first node, or I can just simply right click. And then I can name this anything I want. I am going to call this the north wall. I'm going to give it a 1 since it's my first story. I'm going to enter the type as wall, and then I can enter some meshing information. Now, again, one of your advantages about creating a parametric mesh is that I can change the meshing element size after I see a preview of this. So I'm going to go ahead and say optimize. I'm going to actually keep all of these defaults. Okay. And now here's the option that is really unique. So create density objects from internal nodes and beams. I don't actually have any within this area, but if you did, you can, it will automatically attach itself to any nodes within this plane. Okay. Now, another thing we should talk about upon limitations of working with the RCDC. So we talked a little bit about, we do recommend a different wall, a different parametric model for each level of the structure. We should also mention that currently openings within parametric models are not being brought over to the RCDC, and it is looking for walls that are pretty regular of shape. So you want like a constant height and a constant thickness. So just keep that in mind to make sure that this workflow works for you. So I am not going to add openings at this time, but if you are interested in parametric models as kind of like a standalone option, please note that openings can be added in STAAD.Pro, just not brought over to the RCDC. So once we're done, we'll go ahead and click OK, and this is what my finite element mesh is going to look like. Now again, this isn't in STAAD.Pro. This has not been sent to my input file yet at all. This is the preview. And I can go over here and I can make some changes if I wanted to. Like say, for example, I want a target element size of 2 instead. I'm just going to change my system, go ahead and click apply. Okay, if I wanted to go to more of a triangular mesh, I can do that as well. I find that gives me a much tighter mesh, and I prefer a square mesh if at all possible. And I'm going to leave my target element size set to 3 for this exercise. So here is what my first wall looks like. And I'm going to keep this process up for the remainder of my system. So let's go ahead and I'm going to walk my way around the perimeter. And I'm going to create my walls. Each time, to get that add button back, you're going to go click on preview model again. Now I don't have to create 2 individual bays here. I can go across bays. It'll automatically attach it to the center node. What do we call this? We call this the west wall. Just bear with me as I get the rest of these created. Now, as a reminder, if you have a larger model than this, which you probably do, you can limit what you see in this window by saying, hide different objects. So if you wanted to take a look at just a plane, you can do that, and all these view tools will still work for you. Okay, a couple more to do, and then we're going to show you how to send these over to STAAD.Pro. And the last one. Thank you for your patience. Okay, so I've created my parametric models. What's next? Well, if I like them, if I'm done, modifying them and massaging them the way I want to, I'm ready to send them over to STAAD.Pro. So I'm going to assume I like what I see. I want them now to go over to my input file. So what you're going to do is you're going to identify each parametric model that you officially want to commit to STAAD.Pro. You're going to highlight that model, and then we're going to say merge mesh. And now we can see it because now it's there. Now it's in STAAD.Pro. So I'm going to do that with each of my walls that I just created. Okay, last 2. Okay, now if we go back to our plate layout area, we're going to see all the plates that were generated. All of this is in my input file, and it's ready for me to proceed on with my STAAD.Pro modeling process, which is basically the same process you would do. I'm going to assign a thickness to these just like I normally would. I would assign plate loading if applicable, any analysis commands, supports, and so forth. Now, to save ourselves some time in this session today, I've taken the liberty of completing that model. I actually went with a finer mesh density on this one. I went with the 2-foot element size here, but you're going to see that now I've gotten this model to the point where I'm ready to perform my analysis. So if I look through just to kind of show you what I have here, a plate thickness was assigned to all of these. I'm going with a 12-inch thick concrete wall for today. I assigned the material property of concrete to it. I created some supports. I do have some loading, including some out-of-plane wind loads for plate loading. Those loads, any reactions within the walls will be sent over to the RCDC. We can go to the analysis area, and then to finish this off, we're going to see that I've added an analysis command. I am incorporating p-delta effects into the model, and I'm ready to continue on with my workflow to start thinking about designing these systems. So at this point, I'm going to perform my analysis and hop over to the STAAD RCDC. Now, after my analysis is performed, I'm going to take a look at any errors or warnings. I didn't have any for my particular model, so I'm just going to go ahead and click Done. Now, if there were specific things you wanted to look for in STAAD.Pro after an analysis is performed, of course, you can continue your workflows anyway. If you're looking for things like deflection requirements or reactions, or if you want any contour plots in your finite element mesh, of course, all of that is still available. But when it comes time to design, I want to go with the STAAD Advanced Concrete Design Workflow through the RCDC. Now, when I'm ready to pass my information over to there, I'm going to go to this workflow panel over at the left-hand side of your screen. I'm going to scroll down until I find the Advanced Concrete Design. Now, this is going to officially link this new RCDC model with my STAAD.Pro model. So right now, since I invoked it from STAAD.Pro, it's reading in the model data, and I'm going to enter my information. I'm going to call this my January 2020 SIG. Client is Bentley, and the engineer is myself. And I'm going to enter my design code. Now, again, if you're using older versions of STAAD.Pro, such as STAAD.Pro V8i, you're going to notice that the imperial units might not be available in the RCDC. This is another reason why you may want to, or you're definitely going to want to upgrade to STAAD.Pro Connect Edition so that you can get the imperial versions of the ACI 318. I'm going to use the imperial version of the ACI 318 2014 code. You can see here, automatically grabbed in my STAAD.Pro model, so I don't have to do that. I just need to tell it what I'm working on right now. So the way the RCDC works is we go ahead and we can bring in information from a standalone application, such as STAAD.Pro. It's operated outside the STAAD.Pro environment, but it does require a model and results data from our suitable analysis, which is STAAD.Pro. We're going to design different elements one at a time. So if you were working on beams, you would go to the beam area and you can bring in one story at a time. You can work on footings, pile caps, and slabs as well. Today, we're going to be working on our columns and walls. And actually, I'm going to be focusing this session on the walls since we've already covered columns in a previous special interest group session, but they're done all at the same time. So let's go ahead and ask the program to create a new project for us. Okay, and we can see that our model data has been brought over, including our parametric models. It actually read in the same names that I identified my walls or my parametric models in STAAD.Pro. So let's go ahead and take a look at what came into the model. So automatically we're being placed into this design input area, and the column reference area is active by default. With that, we also have a column layout. Now, if you select any of the items within the column layout, we are going to notice that their pieces of information are going to be highlighted in the column reference table. Let's talk a little bit about how references or reference levels work when information is brought over. So in RCDC, the levels are identified based on unique Y coordinates available from the beam and column nodes. What you're going to notice with my particular model is that I don't have any members that are embedded in the walls. And if you did have such a scenario, that's probably a modeling area that I probably wouldn't recommend at this point, because what would happen is if you had, say, a column embedded in your wall, is it's going to segment that column where it attaches to the wall, and then the level data might not be read in quite properly into the RCDC. So we don't recommend any members or anything being embedded in the walls at this time. So for the cases of a finite element mesh or a parametric surface, a lot of nodes are created for internal plates that are generated, and these plate nodes are ignored for the identification of the levels. So you're going to notice that, again, it's going to take your nodes for your columns as identifying your levels. I do have columns in this system, so it went from 0 to 12 feet and then up from 12 feet to 24 feet. It's not giving me a level at each individual node within the finite element mesh. And of course, you can see that my parametric surface did come in. So this is a vast improvement from the previous versions, knowing that we can create a finite element mesh in STAAD.Pro, and it can come over to the RCDC. So what we've noticed is that our straight wall has come in, and we do have one combined wall. They're calling this CW. CW means combined wall. That basically means when you have two walls that are intersecting each other, they will be brought in together and basically combined for the purposes of the analysis. A few moments after I'm done with the design, I'm going to go ahead and show you how the junction of that combined wall is designed and detailed in the RCDC. So we'll get to that shortly. So once within the RCDC, of course, you can review your input information, and then you're going to customize your settings. Now, again, my focus today is on the concrete walls, but the design settings are applicable to all of the columns and the walls. So you can use this almost as a review for your column design workflow as well. So let's go ahead and start with the design settings. I'm going to take a look at this shear wall information. Now, if you did model your shear walls as members in STAAD.Pro, similar to as we have done in the previous special interest group session, that was before update 3, it will define shear walls. Anything with like a length to width ratio over 4 will be defined as a wall. Anything with a ratio less than that will be designed as a column. And then we also have some different options here. Now, I'm going to go ahead and choose to detail my walls with equal spaced rebar. So if I say equal spaced rebar, it's going to basically space my rebar along the length of the wall pretty uniformly. If I didn't select this, it may identify like end zones within my wall, which may have a tighter rebar spacing. So that's a choice that you can make here, depending upon how you want to detail your concrete walls. I'm going to detail mine with equal spaced reinforcement. I can always change this after I perform the design if I don't love the results. So let's go ahead and click OK there. And I'm also going to go to my reinforcement settings, and here's where I'm going to customize the percentage of reinforcement that I can have, my links that I'm looking for, and also the bar sizes that I like, that I prefer. Typically for walls, I might want to, perhaps for walls and columns, maybe I don't want to go with anything less than, say, a number 5 bar. Maybe I don't want to go with anything larger than a number 8 bar. So I can go ahead and customize this per my specifications. You can enter some detail and drawing settings as well. I'm going to leave everything here set to their default. I think probably everything here is pretty self-explanatory. And you can also enter some zone bar information. Okay. Now, our model isn't quite ready to perform a design yet. The first thing we need to do after reviewing our settings is to review our loading information. So we're going to notice that all of the load cases that I had available in STAAD.Pro have been brought into the RCDC. And now I just need to tell the RCDC to go ahead and use those loads. And to do that, I need to define the type for each load. This will help the program generate its load combinations. I'm going to grab all of these load cases and move them over to the selected area. Once I've done that, I can go ahead and click OK. Now for my STAAD.Pro model, I chose to not generate any load combinations, so I'm going to do that here. If you did generate load combinations that you would like to use, you can grab them from your analysis model. So that's 2 different workflows you do have available for yourself. So you can say here, add from analysis. I'm going to add from a template for regular structures. And here I can preview my load combinations. I entered the proper load type for all of mine. So let's go ahead and click OK. Okay. And if you did want to see any of the information coming in, you can see that here. Let's actually, before we perform the design, let's take a look at the level data. This is where you can create your material properties. So I want to say use C4, 4,000 PSI concrete. So I'm going to do this here. You can change this on an individual member basis later on, but concrete compressive strength, I'm going to say applies to everything. So I'm going to go ahead and enter that information here. And again, you can change your cover, your yield strength of steel, and so forth. At this point in my workflow, I am ready to perform a design. I'm going to come up here and just say design, and then I'm going to tell it to perform an automatic design for me. It's actually designing all of your walls and your columns at the same time. Once the design is performed, you're going to be given a design or column design output table. The first cell within this table is going to be color coded. So anything in green means that it passed, it found a suitable reinforcement layout that passes the code check requirements. Anything in red means that that was a failure, okay? If for whatever reason you want some more information on any failures, you can go down here and say reports, failure diagnostics. I don't have any failed columns. If you wanted to just confirm a little bit more. So let's go back to this column design area. And what we're going to notice is all the data is going to be reported here. CW1, that is my combined wall 1. It basically is combining C1, C4, and C9. It's still, even though it's a mesh, it gives it kind of like a C designation. And on the previous view, I also noticed that C8 is a wall as well. If I didn't write that down, I'd probably be clued in by the reinforcement that that was my other wall, in case you didn't notice what designation it was given. Now, if I want to go back and change any of the settings for my wall, say I'm taking a look at this rebar, maybe I don't like number 5s, maybe I want to change it. Okay, so if you want to change anything, you're going to want to unlock your design, and then you can make changes and then redesign. Okay, those are for things that can be done in the RCDC. If you want to change something else, like say, for example, you want to change the thickness of your wall, we don't recommend changing that in the RCDC, but because of course that can significantly affect your analysis results. So if you find yourself where maybe you had a failure and you have decided that you need to increase your wall thickness for whatever reason, you're going to close out of the RCDC, go back to STAAD.Pro, make that change, reanalyze, and then come back to the RCDC and pick up where you left off. Okay, you've saved this model, so you can just reopen it and resend your model data over. Okay, but you would want to do that in the analysis platform and not over here, since we are basically, if you want to think of this as like a timeline, we are after analysis, and something like changing the stiffness matrix should happen before the analysis. So we need to pick our timeline up where we're supposed to. So let's go ahead and take a look at the few of the ways that we can affect the detailing of our walls. So what you're going to do is, if you want to change the reinforcement, review the reinforcement, we can use the modify menu option to accomplish that. You're going to highlight the wall that you want. I'm highlighting combined wall number 1. And let's pick a few of these options that are available here. So let's go ahead and start with redesign section. Okay, it's going to close my report, basically my failure diagnostics report. It wants to close any reports before it lets you kind of do any modifications. So upon selecting that command, it's going to bring me to the redesign combined wall kind of dialog here at the bottom of my screen. I could change my material properties. Again, I probably think that's better to do before the design globally, but you could change it here if you wanted to. You can see all of your information for this combined wall. And if you wanted to work on, say, one of these segments of your wall, what you're going to do is just double click on the picture of the wall in your screen. And it's going to basically bring it up. And then you can see a lot of the details and information. Again, I'm not going to want to change the thickness of the wall here. I want to do that in STAAD.Pro. What I can do is I can take a look at these bars. So now I've zoomed in. Now, as I mentioned, I changed my design settings to say I want equally spaced reinforcement across the entire length of my wall, which is exactly what it did do. Now, if I had decided not to do that, you're going to notice that it basically broke this wall into 3 zones, like 2 end zones and 1 middle. If I had left that checkbox unselected, what I would expect to see is probably a tighter rebar spacing in my 2 end zones, zone 1 and 3, and a different spacing, possibly further apart, in zone 2 in the middle region of my wall. Now, as I look here, you're going to notice that it's going to truncate this list for available bar sizes to the ones that I selected as what my preferences were. Remember, in the design settings, I said I liked nothing smaller than a number 5, nothing larger than a number 8. And actually, I think I had number 7s not available. So it's kind of truncated this list. It went with number 5s. Now, I can change the bar diameters. I can kind of change that over here if I wanted to. So I can go ahead and change bar diameters through this table, or I can change it interactively over here. So what I'm going to do is I could say change bar diameter. So let's go ahead and select the bar diameter we want. I'm going to go ahead and say number 6s. If I say change bar diameter, I can click on some bars, and basically that pair of bars is going to change. They're going to be color coded now to be number 6s. Okay. If I like that change, I can go ahead and say redesign to kind of check to make sure that new wall or reinforcement arrangement is good. Or I can choose to cancel. I'm going to choose to cancel because I actually like all the same bar sizes available. So that's how we would redesign a section. We can also, and that's for your main like vertical bars. You're going to notice with our design settings that we also had an option for specifying the types of links we like. And we can modify the links as well for a wall. So I still have combined wall number 1 selected. Let's go back to reports, not reports, modify, sorry. I'm going to go with edit link arrangement. And again, I'm given my combined wall. So let's go ahead and zoom in. I'm going to zoom in on this corner area, if I can get my mouse to cooperate. Let's zoom in a little bit. Here we go. Okay. And let me go ahead and advance my PowerPoint slide. Oop. One area. So we're going to notice that this is being designed as a combined wall. So automatically, I created a finite element mesh in STAAD.Pro, where I had basically 2 meshes intersecting each other at 90 degrees. Technically, if I were to take a look at the 3D view in STAAD.Pro, I'd see that the center lines of the walls are basically joining up. So automatically, the RCDC has filled in the rest of this wall. It's not just center lines joining up in, like, say, a missing piece of concrete. It automatically kind of created that corner for me. And what it's going to do is it's going to design each, we'll call this a wing of the wall, and whichever one kind of governs, then that reinforcement is what's going to govern this junction. So it's going to kind of determine what this wall needs, and then it's going to determine the reinforcement at the junction. You will be able to see all of those calculations in the calculation reports, which I'll show you in a moment. And you'll be able to actually see, okay, it analyze the reinforcement for the junction coming from one side, analyze the reinforcement for the junction from the other side, and it will give you a summary table to show how it detailed that corner. So what's happening here is basically the default link setup has been defined. I can create a custom link setup as well. So what I can do is I could say clear the links. Unfortunately, it resets your view when you do that. So I could say clear the links. I could say auto linking. Auto linking is basically what happened automatically. Okay. I could say perhaps that I just want a master link. apologize for my resizing here. I can say I just want a master link, so that's going around. I can also say, you notice that basically every 4 bars had, kind of like the horizontal member that went across. What I can do is I could say, well, I want that kind, but maybe these are so tight, maybe I want it like this instead. Okay, so maybe I want to go like this. So I have the freedom to kind of detail them and draw them the way I want. If I like the master links, I can just go back to the master link layout as well. So I'll go ahead and keep that. And again, if I wanted to globally change any of that criteria, I can unlock my design, go back to my settings, and then we'll be able to redesign after any changes are made. So I'll go ahead and accept this one. I actually didn't really make any changes, and then we'll move on. So now that we've gone over how to modify your design, how to control your design, how to create your mesh, let's take a look at some of our results as well. I'm going to go to my reports area, and I'm going to go to design calculations. Again, I'm going to be picking my combined wall here. If you wanted your other wall, again, we're going to want to remember that that was C8. Okay, so if you wanted that as well. I'm going to pick on my combined wall just to save some time and some length of report that I'm going to go through. So I'm going to go to my combined wall, get a design report, and I'll be able to see all of my calculations for this wall, which would be a great way for you to kind of verify and to understand the full design process that is happening when we hit that design all button. So here you can see all of the checks, calculation for design moment. Here's axial loads, design for shear, design of the links. We have some design summaries. And we're going to scroll down and review this information as needed. Okay, this is what I was just telling you a moment ago. We do provide a table within this area to show the junction. So this is a junction between C1 and C4. Again, you can always go to your main design layout to see which one's C1 and which one's C4. But you can see here how the reinforcement for that junction is determined. Okay, let's go ahead and take a look at just a few other things that I want to show you. And then after that, I'm going to open it up for questions. As a reminder, please feel free to go ahead and enter any questions that you may have in the question and answer window. I'm going to try to hit as many of them as I can. I will be sticking to the questions that are a little bit more applicable to our workflow that we're showing today. And I just realized I didn't show you my edit link arrangement PowerPoint. So here's the workflow that you're going to need for that. I think we already went over that on our screen as well. So let's go ahead and just take a look at a few other things. I just want to show you some of the drawings you can generate, especially if this is your first time coming to the RCDC. So what we're going to do is let's go ahead and go to a detailed drawing. Again, I'm just going to pick my combined wall for the ease of time. I can select which level I'm interested in. And it's going to generate a detailed drawing of my wall. It's also going to give me some information on the links that were detailed for that as well. I'm going to go to my reports again. Let's go ahead and hit the text schedule. And here we can see that we can create a table of information. This is for our combined wall. This is for our other wall. All of this is in CAD format. It can be saved. It can be opened in MicroStation. It can also be opened in AutoCAD. Let's go back to reports. supports one last time, and let's take a look at an elevation of our wall in case you wanted some more information. Of course, all of this is available for columns because we actually, even though we didn't discuss our columns so much, they're in here as well and were designed. Okay, so here we can see our wall elevation as well. Now at this point, let's go ahead and start wrapping up the session, and I'm going to start turning my attention over to the question and answer window. While I do that, you can feel free to take a look at some of our updates for 2020, including a link to our events calendar. I will be providing a quick tour of that at the end of this session. So let me go ahead and take a look at the question and answer area. Again, please feel free to go ahead and enter any information or any questions you might have. And I'm going to go ahead and pick out a few to answer verbally. There we go. Okay, there was a question. Can we generate a bar bending schedule? Yes, you can. In the RCDC, we're going to go to BBS. BBS means bar bending schedule. And we will go ahead and say generate a bar bending schedule. Let's go ahead and do it for our walls. Let me pick one column just so you see what that looks like for a column as well. Let's go ahead and say generate. Okay, some of the drawings just take a few seconds to generate, so just bear with me. Okay, let me see if there's something quick I could answer while we wait for this to generate. So I'm going to go ahead and mark that question as answered. Okay, well, here's a quick one. Someone asked how wall openings work in the RCDC. Currently, wall openings do not import from STAAD.Pro to the RCDC. They do hope to add that functionality at some point, but that's not available as of yet for the parametric surfaces. Okay, I'm reading some more questions and I'm still generating a bar bending schedule, so just bear with me. Okay. That is taking a while. My screen is gray. So let's go ahead and hit some of these other answers, and we're going to wait for that bar bending schedule to appear. Hopefully it will. Okay. Someone asked a question about the local coordinate system of your wall region. Say, for example, I had a wall at my first floor level. We modeled these at like each level at a time. So I modeled a wall at my first floor level. I modeled a wall at my second floor level. And I know probably if a lot of you are experienced with finite element meshes in STAAD.Pro, you might be concerned about where's the direction of your local z-axis. And what if your local z-axis is pointing in one direction on one floor versus another direction on another floor? Oh, this is looking promising. Okay, so the way I'm going to answer that is that you are going to define your finite element mesh. Once you commit it to your input file using the parametric models, you're going to continue on and assign whatever properties to that finite element mesh that you normally would in STAAD.Pro, which includes affecting the direction of the local z-axis. So you can go to STAAD.Pro and highlight the walls you want to change. You can view your local coordinate system. You can change the direction of your local z-axis if you need to. I typically would do that before I added any loading to the wall or reviewed any results. So you can do that and affect that local coordinate system once your mesh is within your system. You don't do that in the parametric model area. You do that in your main STAAD.Pro interface after it's committed to the input file. Okay, let's return to the bar bending schedule. So here we have it. Let me zoom in. This is why it took so long, because there's so much here. Okay, so here we do have a bar bending schedule with all of the tables, available sizes, and so forth. I know it's probably small on your screen because there's a lot of data here, but we can generate a bar bending schedule. This is available for columns. It's also available if you were to like design beams and stuff like that. Okay, there was a question about, can the RCDC work for surfaces that are not parallel to any of the X, Y, and Z axes? This is a two-part question, so I would say yes, it doesn't have to be parallel to the global X, Y, or Z axis. My building structure, as I mentioned, is very simple structure. It's very orthogonal, it's very boxy. Obviously, that's not the case in the real world. But the second part of that question is, say, a circular structure like a tunnel made of multiple nodes. Well, what you're going to notice is I mentioned with the parametric surfaces that they do need to exist in the same plane. So I don't think that the detailing is going to turn out exactly the way you want to if you have a circular system, and you're more than likely not going to use parametric models to create that type of system. So I'd say I don't quite recommend it for, like, say, a round pipe. But for a wall, a solid surface that is regular in shape, it doesn't have to be orthogonal as far as the plan dimension goes, but it should be all in the same plane to create a parametric surface for that. Okay, someone asked, and this goes on to the parametric mesh, if the mesh density is different between two joined walls, will the software merge the common joints into the mesh for the two walls? And this would be along the height of the wall, I'm guessing. So if we take a look at a 90-degree intersection, would it automatically join the walls? If you do have a different mesh density, say my western wall, I did like a 3-foot density, and my northern wall, I did 2-foot density, it will not automatically match those up. It will match up the nodes that are there when it's created. Yeah, it'll create the mesh when it's created. Now, if you were to, and this would be an interesting test, if you were to create that north wall, merge it to your STAAD.Pro model, and then come back and do your western wall, in that scenario, I think it probably would identify them because those would be official nodes in the input file. But since I created all of my parametric models at the same time, it wouldn't necessarily, if I did a different mesh density, it would be a different mesh density. Now, that being said, I do still believe that once I went over to, actually it would, because I tried this yesterday, it would still bring them over to RCDC, still define them as a combined walls. But if you're worried about mesh density and joining nodes, you're either going to want to create one wall first and then create the next one, or choose the same mesh density, which is probably what I would recommend the most. Now, this is an interesting question. I don't think so, but I'll go ahead and hit on it. Can you copy and mirror the parametric model still in the parametric area before you've committed it to the input file? I don't think that that's available. But that would be an interesting thing to be able to see. It'd be nice to be able to just copy and paste if you had two walls that were identical. So that would be interesting. And how do you make sure a slab is connected to a wall? I would say that this is the same as the similar thing. Whenever you have a 90-degree intersection, you can use a parametric surface to create your slab. And but in order for it to be like connected at the same nodes as the wall, I'd probably want to use the same mesh density or create the walls first, come back later and create the slab. So you can create a parametric model for your walls, commit them to the input file, and then come back to parametric and create more. So I would probably do that. Okay, I see a lot of questions here. I'm not going to possibly be able to get to all of them. Let me answer one or two more, and then I do want to move this along, and I want to talk about the events page for Bentley Systems. As always, if you would like, you can see my bio available on your screen. There is a link to my email there, so you can always follow up with an email for me. I did see a question here about having trouble accessing the RCDC. I'm going to go ahead and say that that's probably, you might want to take a look at what you have available and possibly send me an email or your account manager an email if you're having trouble loading the RCDC. But I would take a look at your STAAD.Pro version and make sure that you loaded the RCDC when you installed it. Okay, one